Hello students, I am Azizi, Professor Electronics. In our previous session, we have written an assembly language program that we have developed on Proteus software. First, we'll check our previous simulation and then we'll write a new program for our circuit. So let's start our today's session. And here we have the circuit which we have developed in Proteus for 89C51 microcontroller. As we are learning the assembly language programming techniques using MCS 51 family, and 89C51 microcontroller is a member of MCS 51 family. And here we can find we have connected 8 LEDs on port 0 using the Darlington driver, that is ULN2803. And here we have connected 3 switches on port 2, that is port 2.0, port 2.1 and port 2.2. And we have written a program that if we'll press the switch, that is switch 1, all LEDs will be on, and if we'll release the switch, then all LEDs will be off. Let's check our previously written program. And here we can check all LEDs are off, and if we'll press the switch 1, all 8 LEDs are on, and if we'll release the switch, all 8 LEDs will be off. Now we'll write a program that by default LED 1 will be on and LED 2 will be off, and if we'll press the switch, that is switch 1, LED 1 will be off and LED 2 will be on, and if we'll press the switch 2, the LED 1 will be on and LED 2 will be off. It means that we will write the program for flip-flop circuit. Now first we will check what is flip-flop circuit, and here we will develop our flip-flop circuit using Circuit Wizard software. So first we will go for the gallery, and here we will go for the components, and here we can find 7400 series, that is TTL series ICs, and here we can find different gates are here. We'll use the gate, that is NAND gate. We'll place the NAND gate here, and we'll place the second NAND gate here, and now we'll go for the resistors and switches. Here we have push to make switch, the second switch, and now we'll select the power supply. Here we have power supplies, so we will use a 5-volt power supply to run our circuit. Okay, here we have the 9 volts. Right click, go to the properties, and here we'll set the voltages, that is 5 volts. Okay, and now we'll use some resistors, transistors and LEDs. Here we have LED and the second LED, and here we have resistors folder, and we'll select the resistor like this, and we'll change the value. Right click, properties, and here we will write 4.7K. This resistor will serve as pull-up resistor for our circuit. So here we will connect the switch with the input of NAND gate, and we will connect 4.7K resistor with the switch. Now we'll copy the R1 resistor using Ctrl C. Select the component, Ctrl C and Ctrl V. Here we have the copy of this resistor, that is R2, and now we'll connect the R2 resistance, that is 4.7K resistor, with second NAND gate. And we'll connect the next end of these resistors with the 5 volt. And we'll connect the output of the first NAND gate with the input of second NAND gate like this. And now we'll connect the output of second NAND gate with the input of first NAND gate. And we'll connect the second end of the both switches, that is switch 1 and switch 2, with ground. So we'll select the ground from the power supply section. And here we have ground, and now we'll connect the second end of both the switches with ground, and now we'll drive both the LEDs from the output of NAND gates, and for this we'll select the transistors, and here we have the transistors folder. We'll select NPN transistor, and we will copy this component, that is Q1, Control C, and we will paste it here, Control V. So here we have the second transistor. We will use two resistors to drive these transistors. Now we'll connect both the emitters with ground, and now we'll use the current limiting resistors for both the LEDs. As we have learned that how to calculate the current limiting resistor for the LEDs, if the driving voltages are 5 volt and the forward current of LED is 20 milliampere, then we have calculated that a 150 ohm resistor is required as current limiting resistor for the LED. So we will copy the resistor from here, Control C and Control V. We will connect the resistor with the collector and we will change the value, right click, properties, and here we will write 150 ohm. OK, and here we will connect the cathode of first LED with the resistor like this, and the anodes of both the LEDs will be connected to 5 volt. OK, now right click on LED, properties, and here we can select the color of the LED. The color of the LED 1 is red, or we can select red, yellow, green, amber, blue, white or infrared. So here we have selected red LED. OK, and now we'll change the color of the second LED and we'll change the color to green. OK, here we have completed the circuit for our flip-flop. So if we'll run the simulation, and here we can check by default green LED is on. If we'll press the switch 1, here we can check red LED is on and green LED is off. If we'll press switch 2, the green LED is again on. This circuit is called flip-flop circuit. Now we'll develop the same flip-flop circuit on microcontroller, and we are using 8089C microcontroller, and we'll write the assembly language program for the flip-flop in Microvision Keel. So let's see how we can write our program, and here we can find the program which we have developed in our previous session. Now we'll modify this program for our new task. So first we'll save this file as flip-flop program. So here we'll go to the file and we'll select save as, and here we'll assign the name, that is flip-flop project dot A51. OK, save. We have saved our old program with the new name, that is flip-flop project, because in this program we have already assigned the names for different hardware locations. That's why we have saved the program with the new name. Now we'll close the project. OK, close. Now we'll go for new project, and here we'll assign the name, that is flip-flop project. OK, save. Now we'll select the microcontroller 89C51. OK. No. Go to the target 1, right click, options for target 1, select the crystal oscillator frequency, that is 12 MHz in our case. So here we will write 12.0, and we'll go to the output, that is create hex file. OK. Source group 1, right click, add existing file to source group 1, and here we have our file, that is flip-flop project.a51. OK, add, and here we have our previous program. Now we'll modify this program. First of all, we'll change the name, and here we will write, that is flip-flop project. So here we have changed the name of our project, that is flip-flop project. We'll use the same variables and hardware addresses, that is LED's port is ATH, which is the hardware address of port 0, and here we have assigned the variables, that is switch 1, switch 2 and switch 3 to port 2.0, 2.1 and 2.2, and here we have used two variables, that is LEDs on and LEDs off. Here we can check we have assigned a variable to ATH, hardware location of the port 0. Now we will change this assignment, and we will assign the name, that is LED1 and LED2 to the port, that is port 0.0, and LED2 to the port, that is 0.1. So here we will remove this line from our program, and here we'll assign a new variable, that is LED1, LED underscore 1, and we will use, that is bit, and here we will write, that is port 0.0, as we have connected the first LED, that is D1 on port 0.0, and now we'll assign second variable, that is LED2, and again here we will write, that is bit, and here we will write port 0.1. We can use the hardware address of port 0.0 and port 0.1 instead of using port 0.0 and port 0.1. And here we can check the hardware address for port 0 is 80H. That is the address for whole port, that is port 0. But we can select different bits, that is port 0.0, port 0.1, port 0.2, port 0.3 with their hardware addresses. And the hardware address for port 0.0 is 80H and the hardware address for port 0.1 is 81H. So we can use that is 80H and 81H instead of using port 0.0 and port 0.1. So here we have assigned the names, that is to port 0.0 we have assigned the name that is LED1, and for port 0.1 we have using the variable that is LED2. Now in this program there is no need of variable assignments, so we'll remove the variable assignments from our program. And here we will use the same directives as we have already used in our previous program, that is originate org00h, jump to initialization routine, originate 30H, and from here we will start writing the initialization routine. So here we will initialize the status of the LEDs, that is one LED will be on and the second LED will be off. So in initialization we will turn on the LED1 and turn off the LED2. So here we will change this instruction and we will write that is set bit the LED1 and we will write clear LED underscore 2. We can check from the datasheet of the microcontroller, that is 8089C51 microcontroller. By default the status of the all four ports will be high. So first we will clear all the ports in our initialization routine. So here we will write that is move port 0 comma hash 00H, and we'll write move port 1 comma hash 00H, and we'll write move port 2 comma hash 00H. As we can see, we have connected three switches from port 2.0, 2.1 and port 2.2. We cannot set the value of these ports to 0. We have to set the value of these ports as 1. So what will be the value that we will assign to this port? It means that all the ports, that is from port 2.3 to port 2.7 will be 0, but the status of these three ports will remain high. Otherwise the microcontroller will not accept the status of the switches because our switches are active low. So we'll set all these three ports as 1. So what will be the number that we will move to the port 2? As we can write the port 2 like this, that is port 2.0, port 2.1, and port 2.7. As we have connected the switches on port 2.0, 2.1 and 2.2, so the status of these ports will be high, that is 1, 1, 1, and the status of the ports, that is from port 2.3 to port 2.7 will be 0. So here we will write that is 0 for all ports. Now what will be the number? As we know that the binary weightage of port 2.1 is 1, 2.2, 2, 4, 8, 16, 32, 64 and 128. Here we can see the number, that is 1, 2 and 4 are present, and if we will add these numbers we will get the number that is 7. So in our initialization routine we will assign the value that is 7 to the port 2, and here we will assign the value that is 07H to port 2, and we will assign the value that is 0 to port 3, and here we will write that is move port 3 comma hash 00H. So here we have initialized all four ports. Now we'll come to our main program, and here we will write our flip-flop program. So first we'll remove all these instructions, and from here we can write that is check the status of the switch 1, and here we will write jump not bit, that is switch 1, comma LED 1 on. So here we have written the name of our subroutine, that is LED 1 on, and our program will check if the status of the bit, that is switch 1, will be low, then it will jump to the subroutine, that is LED 1 on, and here on this line, if the program will find that the switch 1 is not pressed, then it will come to the second line, and here on next line we will check the status of the second switch, and we will write that is jump not bit switch underscore 2 comma LED 2 on. So here we will write that is LED 2 underscore on, and if the status of both the switches, that is switch 1 and switch 2, will be 1 or high, then our program will come on third line, and here we will write that is jump main routine. And now we'll write our first routine, that is LED 1 on. So here we will write using colon, and here we will write that is set bit LED 1 and clear LED 2. So here we will write that is set bit LED underscore 1 and clear LED underscore 2, and after executing the subroutine, our program will jump back to the main routine. So here we will write jump main underscore R, and now we'll write the second subroutine, that is LED 2 on. And here we will write clear LED 1 and set bit LED 2, and after executing the subroutine, our program will again jump back to the main routine. So here we will write that is jump main R, and here we have completed our program. And now here we can find we have written the end, and again we will go through our program, and here we have assigned the label, that is LED 1 to port 0.0, LED 2 to port 0.1, switch 1 to port 2.0, switch 2 to port 2.1, switch 3 to port 2.2, and here we have written the directives for our compiler, and we have written the initialization routine from 30H. So here in initialization routine, we have initialized the status of the ports, that is we have moved 00 value to port 0, 00 value for port 1, 7H to port 2 and 0 to port 3, and here we have written set bit LED 1 and clear LED 2. It means that whenever we'll run our program, the LED 1 will be on and LED 2 will be off. And here in main program, we are checking the status of two switches, that is switch 1 and switch 2, that is port 2.0 and port 2.1, and here we are checking that if the status of switch 1 will be low, then our program will jump to the LED on routine, and if the status of the switch 1 will be 1, then our program will come to the next line and it will check. If the switch 2 will be pressed, then it will go to LED 2 on. Here we have written the subroutine, that is LED 2 on. Now if both the switches are not pressed, then our program will again jump back to the main routine and continuously monitor the status of both the switches. If the switch 1 will be pressed, then our program will come to the LED on routine, and here it will set the status of LED 1, and then LED 1 will be on, and it will clear the status of the LED 2, then the LED 2 will be off, and after performing these tasks, our program will again jump back to the main, and in the second subroutine, that is LED 2 on, and here it will clear the status of LED 1. In this case, LED 1 will be off, and it will set bit LED 2. In this case, LED 2 will be on, and by executing these two lines, our program will again jump back to the main. Now we'll compile our program and we'll check the result of our program on Proteus. OK, build. Here we can find 0 error, 0 warnings. Now we'll change the hex file in our microcontroller. Edit properties, go to the program, and here we have our new hex file, that is flip-flop project. OK. And now we'll run the simulation. Here we can check. The value of all ports are 0 as we have written in our program, that is the value of port 1 is 0. Value of port 3 is 0, but the value on port 2 is 7. That is port 2.0, port 2.1 and port 2.2 are high. And in our program, in initialization routine, we have written that in initialization, set the status of port 0.0 as 1 and clear the status of port 0.1 as 0. If we'll press the switch 1, our program will jump to the subroutine, that is LED 1 on, which is already on in initialization routine. So we'll press the switch 2. In this case, our program will jump to the second subroutine, that is switch on LED 2 and switch off LED 1. So we'll press the switch 2. And here we can check LED 2 is on and LED 1 is off. Now if we'll press switch 1, here we can check LED 1 is on and LED 2 is off. So here we have written a program for flip-flop as we have designed using NAND gates, and here we have written the program for flip-flop. And before closing this session, I would like to give you an assignment. Your assignment is that use the same program and modify the program for a new task, and the task will be, if we'll press the switch 1, all LEDs will be on, and if we'll press the switch 2, all LEDs will be off. It is your first assignment for this course. Now we'll learn some more assembly language programming techniques in our new session. Thanks for watching the assembly language programming course. We hope that you find this course very helpful to learn assembly language programming. If you feel that this course contributes and enhances your embedded system design knowledge, then go ahead and hit like, share and subscribe buttons, and do not forget to press bell icon to stay updated with every new upcoming video from Electroeducators as soon as it goes up. Electroeducators also offers technical consultancy in following fields. For assistance regarding technical problems, projects and any consultancy, feel free to reach out at our email address electroeducators@gmail.com. Okay, see you in next lecture.